combination submission for the extra credit, as our extension boards have not come in yet. So this is just the model sim simulation. So if we look here, we have our clock, write, not reset. Clock and write are incrementing, but clock write's incrementing at a slower pace. We have our A address, or B address, or data address, our actual data, our 16 registers, as we expanded our register to a 16 by 16 from an 8 by 16. We have our ALU function select, our A input to the ALU, and our B input to the ALU, and then the output. So if we look up here, write goes high right here, and clock is high. Not reset is always high. Our A address is set to 1010, which corresponds to register 10. So our A address should be the value in register 10. So we take register 10 and we go to ALU A input, and as you can see, it's the same value as register 10. Our B input, or our B address value is 0110, which is 6. So we take register 6, we have this value, and that should be the same as in our input to the B bus of the ALU, which is the same. We take this, yep, they are the same value. To show functionality, so not since we get here, write goes high, it's able to actually start writing things. We have 0101, which is negate, so it just gives all, which is actually 0, gives all zeros, and showing that that is working. And then if we move to the next positive clock edge, it writes new values, I believe. Let me check. Yep. So now our new address is 3, register 3. We take register 3, and we have this value in A. If we go to A, that is the same value, if I'm not mistaken. Yep, that's the same value. If we go to B, we have 15. So we take register 15, which is this value actually, because it's the most updated value. And that should be the same as here, which it is. And then they update once more right here, next positive clock edge. We now have registered, it's still the same value, but it might have pushed new values. Yeah, it pushed new value from D. D gets a new value. It's pushing that onto both of these, actually. Yeah, it pushes this value onto those two registers, onto register 3 and register 15. So register 3 has that value. Yeah. So then we get onto our next function select bit, or ALU bit operation, which is 1001, which I believe is OR. Let me just check real quick. Yep, 1001 is OR. So it should be ORing the two values on the A and B bus, so this value and this value, which if you take these two and OR them, you would get this 0, 0, 0, and 1, and wherever there's a 1 on either side, it updates to it, which shows that the ALU is functioning correctly. And then if we just run through the simulation down, as time goes on, all the registers seem to start to fill up. ALU continues operating, choosing a random value for D, random values for the A address and the B address, and random function selects for the ALU. Our write signal increments up and down.